ಗೈಡ್ ಮಾಡ್ತೀನಿ, ಅಲ್ಲಿ ಅವ್ರು ಬಂದು ಐಟಮ್ ಕೊಡ್ತಾರೆ ತಗೊಳಕ್ಕೆ.
So good evening, all of you.
Good evening, sir.
So let us start this session. So yesterday we completed chemical equilibrium. Now in this session we'll see acids and bases. Okay. So let us start this session. So first we'll see Arrhenius acid-base theory. Second, according to Arrhenius, what is an acid? An acid is any substance which produces H plus ions in aqueous solution. Similarly, base is a substance which produces OH minus ions in aqueous solution. So what is an acid? Which produces H plus ion. Base is which produces OH minus ion, but both are produced in aqueous solution only. Then according to Arrhenius, neutralization. So what is neutralization? So neutralization is acid plus base gives salt plus water. Let us suppose HCl plus NaOH gives NaCl plus water. But this theory could not explain drawbacks. Okay. Now, this theory could not explain acidic nature of CO2, P2O5, Cl2O7. So all these are acidic compounds, but why they are acidic, there is no proper explanation given by Arrhenius. The next theory was proposed by Bronsted. So Bronsted-Lowry acid-base theory. Now, according to Bronsted, what is an acid? Proton donor. Proton donor, that means which can donate proton, like HCl, H2SO4, H3PO4. So all these substances can produce, can donate proton. So they're all considered as acids. Next one will be base. What is a base? Proton acceptor. What is base? Proton acceptor. So this is considered as a base. And according to Bronsted, what is neutralization? Transfer of proton from an acid to base. Transfer of proton from an acid to base. That is what we call neutralization. Example, let us consider HCl, which can donate protons. So this can be considered as acid. And ammonia. What is ammonia? Which can accept this proton. Why? So ammonia has lone pair of electrons, so it can accept this proton. So what you are getting here? NH4 plus and Cl minus. Okay, this is base. Then conjugate acid base pair. Conjugate acid base pair. So this is one area where there is a probability of getting a question here. So what is conjugate acid base theory? According to conjugate acid base theory, an acid base pair which differ by a single proton, which differ by a single proton. So that is what we call acid base pair, right? Now, example for this. If you consider HCl and Cl minus, these two are differing by single proton. So this can be considered as a conjugate acid base pair. Okay. Similarly, H2SO4, HSO4 minus. Now here again, they are differing by a single proton, right? So what is H2SO4? Acid. If you remove a proton from acid, you will get its conjugate base. You will get its conjugate base. Okay. Now, conjugate base of weak acid is strong. Means conjugate base formed by weak acid is strong. Example, I'll give you an example. Acetic acid, CH3COOH. This is acid, weak acid. Now it produces CH3CO minus plus H plus. Now the formed base is strong. So this is strong conjugate base. So CH3COH is weak acid, but CH3CO minus is a strong conjugate base. It is strong conjugate base. Next. Lewis acid base theory. According to Lewis, what is an acid base? Acid electron pair acceptor. Electron pair acceptor is called Lewis acid. What is base? Electron pair donor. What is base? Electron pair donor. So that is what we call Lewis base. Lewis base. Types of Lewis acids. In the first one, all simple cations. Examples: Cu plus, Fe plus 2, Ni plus 2. Next one, atoms with electron sextet. That means having 6 electrons. Having 6 electrons in the outermost shell. Example, oxygen. What is example oxygen? 1s2, 2s2, 2p4. Now in the valence shell of oxygen, how many electrons are there? 6 electrons. So oxygen is a atom with electron sextet. Next, compounds in which the central atom can expand its octet. Then types of Lewis bases. All anions B. Compounds. What are all anions? You can take any anion, Cl minus, OH minus, Cn minus, Br minus. Second type, compounds in which the central atom has lone pair electrons. Lone pair electrons. Example for this, NH3, central atom is having water, oxygen is having lone pair, ROH, alcohols, ethers also having lone pair electrons. So which can donate lone pair of electrons. So these are all types of Lewis bases. Then we'll move to pH scale. pH. What is pH? pH is calculated by using negative logarithm of concentration of H plus ions. Similarly, POH, negative logarithm of concentration of OH minus ions. Then pH plus POH is always equal to 14. Okay. Then concentration of H plus ion is equal to 10 power minus pH. Similarly, concentration of OH minus ions will be equal to 10 power minus POH. So this is all about pH. Next, ionic product of water. This is represented by Kw. Kw is nothing but concentration of H plus ions and concentration of OH minus ions. Concentration of H plus ions can be represented by H3O plus OH minus. Okay. Now at 298 Kelvin, concentration of H plus ion is equal to 1 into 10 power minus 7 moles per liter. A concentration of OH minus will be equal to again 1 into 10 power minus 7 moles per liter. And finally, Kw value will be equal to 1 into 10 power minus 14 mole square per liter square. So this is about Kw. Done. So next we'll move to strength of acids and bases. First one, dissociation of acids. Let us consider for any weak acid. For any weak acid, okay, HA gives H plus and A minus. Okay, this is a reversible reaction. So once again, I'll take that reaction. HA is dissociated into H plus and A minus. Okay. Now, initial case, HA will be 1, product's concentration will be 0. After dissociation, what will be the concentration of HAB? Let be C. Then what it will become? 1 minus alpha. This is alpha and alpha, right? Then acid dissociation constant. What is the formula? This will be C alpha. Concentration also consider C alpha, C alpha. Then K is equal to concentration of products. Products are cation and anion by concentration of HA. Right? Now substitute these values after dissociation. So therefore, finally Ka becomes, what is concentration of H plus? C alpha, A minus C alpha by HA, C into 1 minus alpha, C into 1 minus alpha. Okay, and what it will be? So let us simplify this. Acid dissociation constant Ka is equal to C square alpha square by C into 1 minus alpha. So this C and square gets cancelled. Therefore, finally what you are getting, Ka is equal to C alpha square by 1 minus alpha. But for very weak acids, Ka becomes this alpha in the denominator can be neglected. So it becomes C alpha square. It becomes C alpha square. Then what is alpha square? Then Ka by C, or alpha is equal to square root of Ka by C, right? So this is of what is alpha? Degree of dissociation. What is alpha, sir? Degree of dissociation. Done. Next. Similarly, consider base also. Similarly, consider base also, right? For any weak base, POH gives rise to B plus and OH minus. Initially, same will come here, sir. This is 1 unity 0 0. Then after dissociation of base, so this will be 1 minus alpha multiplied by concentration. This will be C alpha, this will be C alpha. Similarly, base dissociation constant is given by concentration of products divided by concentration of reactants. Now let us substitute those values. What is B plus concentration? C alpha into C alpha by BOH concentration, C into 1 minus alpha, which is equal to C square alpha square by C into 1 minus alpha. The C and square gets cancelled. And finally, again, you will get Kb is equal to what you are getting here, C alpha square by 1 minus alpha. C alpha square by 1 minus alpha, where alpha is dissociation, degree of dissociation of base. Okay, but for weak acids, Kb becomes, here this alpha can be neglected, C alpha square. Similarly, alpha square is equal to Kb by C, or alpha is equal to square root of Kb by C. Okay, now this is alpha expression, right? So this is about strength of acids and bases, how we can determine. So next question is, So regarding this buffer solution, so very important. So what is buffer solution? A solution which resists to change in its pH, pH by the addition of strong acid or strong base. So if you add a strong acid or strong base to any substance, then definitely the pH should change. But this buffer solution resists to change in its pH. That means it does not allow to change in its pH even if you add strong acid or strong base. Strong acid or strong base. Such a solution is called buffer solution. And types of buffer solutions. How many types are there in the first one? Acidic buffer. So what is acidic buffer? Acidic buffer is nothing but a mixture of weak acid and its salt of strong base. Salt of strong base. So that is what we call acidic buffer. That is what we call acidic buffer, right? So next, examples for this. Let's see examples for this. So acidic buffer example is weak acid. You can consider. What is weak acid? CH3, COOH, and it's salt of strong base. Salt of strong base, right? What will be strong as a strong base? NaOH. Take NaOH, then what you will get? CH3, COO, Na. Now, pH of acidic buffer solution is determined by pKb minus log of concentration of salt by concentration of acid. Next one, basic buffer solution. Basic buffer solution. So it is a mixture of weak base and its salt of strong acid. Salt of strong acid. Then examples. Then let us see examples. And just one correction here. One correction, small correction here. pKa plus. So here example, weak base, ammonium hydroxide plus its salt of strong acid, ammonium chloride. Then pH of basic buffer solution, pH of BH. So we calculate POH is equal to pKb plus log of concentration of salt the concentration of base. So this is used to calculate pOH of basic buffer solution, right? So this is all about buffer solutions. It's all about buffer solutions. Next, solubility product. So this is represented by KSP. So KSP is nothing but concentration of cations multiplied by concentration of anions. Understood? Let us consider an example. Barium sulfate dissociates into Ba plus 2 and SO4 minus 2. Now, what is equilibrium constant for this? Concentration of products by concentration of reactant. Now here, bring this barium sulfate towards the equilibrium constant. And what will happen? Concentration of barium ions and the concentration of sulfate ions. So therefore, this entire term is considered as a solubility product. KSP is equal to concentration of Ba plus 2 and concentration of SO4 minus 2. That is cation and anion concentration. Okay. Now, let us consider its expression now. Is converted into Ba plus 2 and SO4 minus 2. That its solubility will be S. Solubility will be S. Then KSP is equal to, what is its concentration? S into S. That is S square. Our solubility is equal to square root of KSP. So this is one model. Let us suppose if we consider AB2 type salt. Okay, what does that mean? AB2, A plus, sorry, AB2 gives rise to A plus 2 plus 2B minus. Okay, now let us suppose its solubility is 2S. Then what is KSP? Concentration of A plus 2, concentration of B minus power 2. So what is concentration of B minus S into 2S whole square. So S into 4S square is equal to 4S cube. So therefore, KSP is equal to 4S cube, right? So once again, I'll write here 4S cube. So therefore, S cube is equal to therefore S is equal to KSP by 4 whole power 1 by 3. So this is, I'll find out solubility products of different substances, right? So now let us move to numerical part. So which is more important for us. So we'll solve some MCQs now. So we'll get some idea like how to solve these questions based on acid-base reactions. So very important, every year almost they're giving at least one question. They're giving at least one question, right? So let us see them. We'll solve some questions. So, first question. conjugate base for Bronsted acids, H2O and HF are. Options given are H3O plus and H2F plus. Next, OH minus and H2F plus. Third one, H3O plus and F minus. Fourth one, OH minus and F minus. So these are the options given for you. Right. Then what is the correct option? Just think what is we need. We need conjugate base. We need conjugate base for them. Okay. Now how you will get conjugate base? By removal of a proton from acids. Bronsted acids are given. So Bronsted acid minus proton gives you Bronsted. What we need? Conjugate base. Bronsted conjugate base. Now let us consider these two, H2O and HF. Bronsted acid is H2O. Remove one proton from this, then what you will get? H plus is over, OH minus. So for H2O, what is conjugate base? OH minus. What is conjugate base? OH minus. Next case, HF. From HF also remove one proton, then what you will get? F minus. What you will get? So this will be the conjugate base. So what are conjugate bases for H2 and HF? OH minus and F minus. So what is correct option, sir? The last option is your correct option. Done.
Yes, sir.
Next question, similar to this. You try to answer this question. Give me answer for this question. Yeah. Which of the following cannot act? Which of the following cannot act both as Bronsted acid and as Bronsted base? This is the question. Options given are HCO3 minus, B NH3, C HCl, D HSO4 minus. Now these are the options given. Now according to that question, which of the following cannot act both as Bronsted acid as well as Bronsted base? Okay. Then just try to solve that question. So I'm taking options here one by one. HCO3 minus. So let us suppose if we add HCl. Okay, let me check that HCl now.
Sorry,
So
NH3.
HCl. Can we add a proton to this HCl? Is it possible? No. Okay. So what does that mean? If we add a proton, then it will become Bronsted. That That means HCl, remove proton from this. What you will get? Cl minus, isn't it? So this is acid and this will become its conjugate base. But here HCl cannot accept a proton. HCl cannot accept a proton. That means it cannot act as a proton acceptor is base. So it cannot act as a base. It cannot act as a base. Did you understand? So this is about HCl. So HCl cannot act as both Bronsted acid as well as Bronsted base, right? Then which is the strongest acid? This is one frequently asking question, strength of acids, based on strength of acids. Which is the strongest acid in the following? This is the question. Options given are HClO4, H2SO3, H2SO4, HClO3.
H2SO4, sir.
H2SO4 is strong acid, right? So, so one student is saying that H2SO4 will be the strongest acid among all those options. Among all those options, right? Any other answers? That's it. No other answers. Okay, now such questions you follow always when different compounds are given, then we cannot say by simply saying the formula, which one is strong acid or which one is weak acid. So I'm giving you one generalization here. Strength of acid is directly proportional to oxidation number. What is hydrogen oxidation state? +1. Chlorine, we have to find out X. Oxygen -2. 4 into -2. What you are getting? X minus 7 is equal to 0. X equal to +7. So your chlorine oxidation state is +7. Then H2SO3. 2 hydrogens plus sulfur, we have to find out 3 into oxygen. Should be equal to 0 because there is no charge on that molecule. So this is +2, 2 into +1, +2, plus X, oxygen -2. What you are getting? -6 plus 2, -4. So X equal to +4. So here sulfur oxidation state is +4. Next, H2SO4, all of you know very well what is oxidation state. 2 plus X plus 4 into -2 is equal to 0. So X equal to +6. So sulfur oxidation state is +6 here. Last one, HClO3. +1 chlorine X, oxygen 3 into -2 equal to 0. So then what you're getting? X equal to +5. So who is having highest oxidation state? HClO4. So this is having a higher oxidation number. So it is having highest strength of acid. So which one is the strongest acid in the following given compounds? Your answer should be HClO4. How, sir? So we can determine strength of acid by using oxidation number. Done. Just make a note of this. Okay, shall we proceed then for next question? Okay. So next question. Conjugate acid of NH2 minus. Conjugate acid of NH2 minus. Okay. Now from acid, how you will get conjugate base? By removal of one proton. Then if you are given a base, then how you will get its conjugate acid? By adding of a proton. So add proton to that. Then what will be your answer? So NH2 minus, add proton.
NH3.
You get NH3. So this will be your answer. So conjugate acid of NH2 minus is NH3. Next compound. The strongest conjugate base is, next question. The strongest conjugate bases. I'll give you options here. SO4 minus 2, Cl minus, NO3 minus, CH3, COO minus. Can you determine which option?
Option D,
Why is it so?
because it's a conjugate base of weak acid.
Conjugate base of weak acid is strong. We know that acetic acid is weak acid. So it produces CH3CO minus plus H plus. Now this is a strong conjugate base. Okay, so that is about
Sir, CH3O minus is strong than CH3COO minus, sir.
come again.
Sir, the conjugate base of methanol is strong than acetic acid, sir.
CH3OH.
Is it strong than that CH3COO minus, sir?
This one CH3O minus.
Sir.
Yeah, because methanol is more weak acid than acetic acid. Because methanol does not belong to carboxylic acid group. So it is not actually acid. It is alcohol. But it shows acidic nature. So obviously, it is definitely more weaker acid than acetic acid. Right? So this is more weaker than acetic acid.
Yes, sir.
More weaker acid means the formed conjugate base will be more stronger. So when compared with basicity, that means acetate ion and methoxide ion. No doubt methoxide ion is more stronger base.
Yes,
Is
sir.
that clear?
Yes, sir.
So let us move to one more. We'll do one numerical now. Okay. So based on solubility product. Based on solubility product. Okay. Write down question. Find out the solubility of. Find out solubility. That means yes of nickel hydroxide in 0.1 molar NaOH. Given that, means what is given? Given that the ionic product of nickel hydroxide is 2 into 10 power minus 15. Options given are 2 into 10 power minus 13 molar, 2 into 10 power minus 8 molar, C 1 into 10 power minus 13 molar, D 1 into 10 power 8 molar. So this is given. Okay. What we need to find out the solubility of nickel hydroxide in 0.1 molar NaOH, right? NaOH, how it dissociates, sir? Na plus and OH minus. What is the concentration of NaOH ions given 0.1 molar? That means 1 molar of NaOH produces 1 molar of Na plus and 1 molar of OH minus. That means they are also having the same concentration, 0.1 molar, 0.1 molar. Then here, according to this, concentration of OH minus will be 0.1 molar. Concentration of OH minus ions will be 0.1 molar. Right. Then what is ionic product of nickel hydroxide? Because we need nickel hydroxide solubility. Then what is ionic product of NaOH taken twice? So ionic product of NaOH taken twice. Concentration of cations into concentration of anions. So H minus taken twice. That means power 2. Right. So what is ionic product is given? This ionic product is given 2 into 10 power minus 15, which is equal to Let us suppose solubility of Na plus 2. We don't know that. Let us consider S. And what is concentration of OH minus ion? 0.1. And it is given square here. So 0.1 whole square. Then you can proceed. This is simple now. What we need? Solubility only. So you will get solubility. Solubility is equal to 2 into 10 power minus 15 by 0.1 whole square. Okay. And how to solve this? So final step, 2 into 10 power minus 15. 0.1 means 1 by 10 into 1 by 10 whole square, right? So what you're getting? 2 into 10 power minus 15, 1 by 100. So bring it here. So 2 into 10 power minus 15, 100 it becomes 10 square, isn't it? So 2 into 10 power minus 15 plus 2. 10 power minus 13. 10 power minus 13. So where is it? 2 into 10 power minus 13. So first option itself. What is the answer? First option itself. Done. So this is how you should solve questions based on solubility. Next, let us solve how to find out pH of a given solution. We'll move to pH of a given solution. Question is, the pH of 0.01 molar NaOH solution will be. Options given are A 7.01, B 2, C 12, D 9. So these are the options given. Okay. Then what is formula for calculating pH? pH is equal to negative logarithm of negative logarithm of
Power of hydrogen.
yes, but what is given here, sir? It is not given acid here. What it is given? Base is given. So base is given means what we can consider? POH. POH is equal to negative logarithm of concentration of OH minus ion. So what is OH minus ion's concentration? 0.01 molar. What is given? 0.01 molar. So negative logarithm of 0.01. So how we can write 0.01? And write it as 10 power minus 2. So now here log x power y is equal to y log x. Here log x power y becomes y log x, that is minus of minus 2 to log 10. Log 10 to the base 10, 1. Minus of minus plus. So 2. So what you are getting there? 2.
So
Now,
the answer is 12, sir. Answer is C, 12.
Answer is C. Yeah. Now we got POH. POH is equal to 2. But we know that pH plus POH is equal to 14. And pH is equal to 14 minus POH. That means 14 minus what is POH we obtained? 2. So your answer will be 12. So pH of the given solution is 12. Done. Let us make it a little bit more complex in the next problem. Okay. So let us see. One more question. What is the pH of the resulting solution Resulting solution means we are mixing two solutions. Resulting solution when equal volumes of 0.1 molar NaOH and 0.01 molar HCl are mixed. Okay, options given are 2.0, 7.0, 1.04, D 12.65. So what is pH of the resulting solution when equal volumes of 0.1 molar NaOH and 0.01 molar HCl are mixed? So this is the question. How? But to find out resulting solution pH, sir. Resulting solution pH. Now here the reaction is between 0.1 molar NaOH and 0.01 molar HCl are mixed. Okay. Now here equal volumes, sir. What is it? Equal volumes. Let us proceed with it. NaOH plus HCl gives rise to NaCl plus H2O. This is actual reaction, right? When equal volumes of 0.1 molar, so this is 0.1 molar given. HCl 0.01 molar, 0.01 molar, right? But according to the equation, 1 mole of NaOH neutralizes 1 mole of HCl. That means 0.1 molar of NaOH requires 0.01 molar HCl. Means 0.1 molar NaOH will neutralize 0.1 molar HCl. But here it is not given 0.01 molar. How many? 0.01 molar HCl only. That means to neutralize 0.01 molar HCl, we need only 0.01 molar NaOH. So that means the total concentration is actually 0.1 molar NaOH. Out of 0.1 molar, only 0.01 molar NaOH is consumed. Then unreacted NaOH in the solution will be 0.1 minus 0.01. So what is remaining, sir? 0.01 molar NaOH solution. So the solution which is present, base is present. The solution, what is present, sir? 0.01 molar. So what is concentration of OH minus from this? Number of moles of NaOH remains unreacted, that is 0.01. Here equal volumes. That means volume of OH minus will be 2 because the total will be 1 plus 1, 2. So volume of OH minus will be divided by 2, half. So 0.09 by 2 is 0.045 molar, 0.045 molar. So now by using this we can calculate POH, negative logarithm of concentration of OH minus. Negative logarithm of concentration of OH minus. So negative log, what is concentration of OH minus? 0.045. So log 0.045, if you consider you will get 1.35. So what is POH, sir? 1.35. So no need to worry about logarithmic values. They will give you in the question itself those logarithmic values. No need to worry. Then finally pH is equal to 14 minus POH. That is 14 minus 1.35. So what you will get? 14 minus 1.35, you will get 12.65. So this is your answer, 12.65. Okay. Right. This is based on mixing of solutions. Next.
Sir, do one more problem based on that product, sir. Ionic product.
Ionic product.
Yes, sir.
Okay, let me check one more problem then. Just 1 minute. Okay, one question. So let us see. At 100 degrees Celsius, the ionic product of water, is 55 times. 55 times its value at 25 degrees Celsius. What will be the pH? What will be the pH of neutral solution? So here one hint is given that log 55 is equal to 1.74. So this is the only hint given to solve this question. And how to solve this? So given condition is the ionic product of water is how many times greater, sir? 50 times. Actually, at 25 degrees Celsius or 298 Kelvin. Already I have given you that value. Ionic product is given by 1 into 10 power minus 14 mole square per liter square. So this is already we know, isn't it?
Yes, sir.
Okay. Now, at 25 degrees, concentration of H plus ion should be equal to concentration of OH minus ions. That means what is KW expression actually? H plus and OH minus. So here, if both concentrations are same, then KW becomes a concentration of H plus whole square. Concentration of H plus whole square. Because our task is to find out pH. If you want to find out pH, first you should know what is concentration of H plus ions. That is why you are proceeding in this manner, right? Then next, what is KW? Concentration of H plus ion will become square root of KW. So what is given value? 55 times 55 into 10 power minus 14. So this is concentration of H plus ions. But what we need? pH. pH is equal to negative logarithm of concentration of H plus ions. Now proceed with this. So pH is equal to what you get? Negative logarithm of square root of 55 into 10 power minus 14. Log xy. Log xy. Okay, now let us convert this completely, make it into 55 into 10 power minus 14 whole power minus 2, 1 by 2. Root becomes power 1 by 2, right? Log x power y becomes y log x. What you are getting? Half into minus log of 55 into 10 power minus 14. Okay, now keep this half as it is. Minus log xy. What it will become? Log x plus y. So minus, what you are getting? Log 55 plus log minus 14. Again, it will become y log x. So minus or minus plus log 14. 14 will come here. 14 log 10. Okay, log 10 is 1. So that will become plus 14 minus log 55. Log 55 value is already given. That is that. Minus 1.74. Just substitute that value here. What you are getting here is equal to half into minus 1.74 plus 14. And half of 14 minus 1.74. 14 minus 1.74. What you are getting here? 12.26. So 2 in 12.26 is around 6.13. So this will be your answer for that question, 6.13. Done.
Yes, sir.
Next. One simple question. One more question. The ionic product of water at 25 degrees Celsius is 10 power minus 14. Another question. Its ionic product at 90 degrees Celsius will be. Options given are, I'll give you options. 1 into 10 power minus 14, same. Next, 1 into 10 power minus 16. 1 into 10 power minus 20. Last option, 1 into 10 power minus 12. So which option you will take here?
Sir, option D.
Why?
Sir, as temperature increases, the ionic product decreases, sir.
Ionic product decreases, sir.
Yes, sir.
So according to his statement, what is it? Can you repeat it? As temperature increases,
Increases. Ionic product decreases, sir.
ionic product decreases. Okay. So let us discuss this point for a moment. As temperature increases, ionic product is decreasing. So is it true? What is ionic product of water? It is concentration of H plus ions and OH minus ions. Now the given condition here, it is very clear that 25 degrees is increased to 90 degrees. So no doubt temperature is increased. So if temperature is increased, then degree of dissociation will increase or decrease?
Increase, sir.
Degree of dissociation increases. That means concentration of H plus ions increases, concentration of OH minus increases. So as the temperature increases, ionic product will not decrease. Ionic product of water will increase because you will get more number of H plus ions and more number of OH minus, because degree of dissociation will increase. So this is Kw value at lower temperature, and Kw value at higher temperature should be more than 10 power minus 14, more than 10 power minus 14. So which is having more than 10 power minus 14? That is D, which is having more than 10 power minus 14 is 1 into 10 power minus 12. Okay, your answer is correct, but explanation is not justifying that answer. Okay, actually it is as temperature increases, ionic product of water also increases. So the ionic product of water value at lower temperature should be less than the ionic product of water at higher temperature. Okay, so in that case again option will be same, but it's not a lower value, sir. It is higher value. 1 by 10 power 12 is more than 10 power minus 14. So this is how you should think. 10 power minus 14 means 1 by 10 power 14. Understood? 10 power minus 12 means 1 by 10 power 12. So who will give you more value? I'll give you one example here. 1 by 10, 1 by 100, it is more, right? 100 is more. 1 by 10, 1 by 10. So 1 by 100, what you will get? Lesser value. 1 by 100 is lesser value. 1 by 10 will be 0.1. So if numerator part is less, you will get final value more. So in that case, 10 power minus 12 will be more than that of 10 power minus 14. Right? So this is about acids and bases. So we completed completely ionic equilibrium, as well as yesterday we completed chemical equilibrium also. Right? So tomorrow, I think you don't have class. So we'll discuss remaining chapters. I think we need to discuss thermodynamics on Monday. So you'll see thermodynamics on Monday then, right? So meet you on Monday then. Have a nice day. Good night, all of you.